So XML is pretty stable in that it was very clearly defined at the beginning, so there isn't a whole lot to change about XML parsing. What I started to talk about a minute ago was some of the stuff that might happen in the future in terms of parsing. Ian Hickson is working on defining how this backwards compatible HTML parsing works in HTML5. And we'll probably be looking to implement some of that in Mozilla as the specification becomes more stable. So there may be, in the past, we've avoided breaking the HTML parser by simply not touching it. And if you know that it sort of works and know that people test their web pages in Mozilla, then as long as you don't change anything, it'll still work. This gets sort of dangerous when then we want to change it now so that we improve our interoperability with other browsers. So one of the problems we're running into is that we need a lot more tests to test the behavior that our parser has that's important for web compatibility. So moving on to the tree that is constructed. So when we build a parse tree, the objects that we're putting in this tree have various types and the type of the object has to do with a lot of element-specific behavior and things like. And so what APIs are specific to an element, what things that need to be stored are specific to a type of element, and so on. So the nodes in the document tree are nodes out of a C++ class hierarchy, where the root of this hierarchy is a node interface. And then derived from node, you have a type for a document, and a type for an element, and a type for a piece of text content. And then you have subclasses of the element type for HTML elements, or SVG elements, or Zool elements. And then further subclasses of HTML element types for things like an HTML table element. So that there are many scripting APIs that we implement where, for example, if you're writing JavaScript that uses an HTML table element, there are methods you can call that have things to do with rows and columns. And those methods end up being implemented on this table element object. So it's important that we've constructed the right type of object for that element, essentially. So the code for all of these objects sort of lives in this the content subdirectory in Mozilla, essentially. So we sort of have one directory that has these base classes, like the generic element type and the document type. And then other directories that have all the specific implementations for the various languages. So a directory of HTML implementations and Zool implementations and SVG implementations. So these nodes are, the elements in this tree are responsible for storing a bunch of different things. Going back to this markup example, everything that's in here that we want to keep and use later has to be stored in the content tree. So the name of the tag has to be stored in the content tree. Its namespace has to be stored in the content tree. The attributes have to be stored in the content tree, and so on. They also store some other things. So they store form state. So HTML inputs are actually, text inputs are actually a bad example because they're the one exception to this rule. But if they weren't an exception, if I typed some extra characters into that input, the data would be stored on the node in the content tree. If I change the current value of this selection to a different one, the fact that that has changed also ends up being stored in the content tree. So the content tree is also going to store any state that's changed as a result of script. So if I do something like set attribute border 5, then that change that I've set an attribute is going to be stored in the content tree, just like it would have been had it been in the markup originally. And in fact, once that change has been made, we can't tell anymore that it was set dynamically rather than set in the markup. So there are a bunch of other things within the layout code, within our code that operate on the content tree. So handling of DOM events. For example, when you click the mouse or move the mouse or press a key, there's an event object generated that, and there are a number of ways that web pages can look at the properties of that event and find out that that event happened and so on. Most of the way that this event handling works is done on operations over the content tree, because events, you can do operations on events that happen in any descendants in the content tree, and essentially the event propagates down and up through the content tree. There are a bunch of Zool-related things like overlays and templates that operate on the content tree. I don't want to talk further about them, but they're used pretty extensively in the Firefox user interface. If you write an extension, any extension that shows up in the Firefox user interface somehow is going to use Zool overlays to essentially add extra content into the content tree from another file that wasn't in the original Zool file that displays the browser window. To me, then, the most important thing that uses the content tree is actually all the layout code. So CSS, which is cascading style sheets, is defined in terms of operating on the content tree. And then really a lot of the layout code that does presentation operates on top of both the content tree and the results of CSS. So moving on from document formats into presentation, I want to start by talking about cascading style sheets, which are a set of W3C standards that describe presentation of web pages. So CSS defines a processing model that is sufficient to describe how HTML is presented, even if it never uses CSS. So the CSS specification sort of gives an example of how you might present HTML. It's really just an example, and it's not exactly how everyone does it. But what this means is that Gecko is implemented, and this was, in some sense, another one of the big architectural changes that happened between Netscape 4 and Mozilla, is that Mozilla's layout code is primarily an implementation of CSS, and it uses the rules in CSS to present HTML, even if that HTML uses no CSS, because it's using the model that CSS defines to present the HTML. So